Hi, today I'm going to show you how to use the product and quotient rules for multiplying complex numbers when they're written in mod arg form. So here's what it looks like. So if you multiply two complex numbers, remember it's in mod arg form or cis form, what you do is you multiply their moduluses and you add their arguments, making sure you split up your cos and your sine still. If it's a quotient, so it's a division of complex numbers, we divide their moduluses and we subtract their arguments. Be careful you always put the argument of the first complex number first when you subtract, because then you'll get a different answer. Okay, so what I'm going to do is I'm going to multiply two complex numbers together. So this is written in mod arg form. So it might be written as r cis theta, but this is the same thing. So complex number 1 has modulus r1, an argument of theta 1. Complex number 2 has modulus of r2 and argument of theta 2. So when you multiply them together, we're just going to multiply these two. So what we can do is we'll write r1, I'm not going to write it all out, all that, multiplied by r2, multiplied by all that. Now if we just group a few things together, this is what we get. So we get r1 times r2 out the front, and then what we're going to do is I'm going to multiply these two brackets together. I'll just write that in. Okay, so this is what we've got. We've got r1 times r2 out the front. Now what I'm going to do is I'm going to expand this out. So I'm going to multiply that by that, that by that, that by that, and that by that. So I'll write it all out and you can have a look at it. So if you multiply it out, we get cos theta 1, cos theta 2. Now I actually multiplied these two together here before I did all the other stuff. I did my last ones first because I wanted to put that near it. And then the other expansion, so that times that and that one times that one is written over here. Now as you know, I squared is really minus 1. So I'm going to change that just to a negative in there. Now what we're going to do is we're going to simplify this. Now you'll notice a couple of things. I'm going to group these together. That there and that there looks like something you've seen before. And what it looks like, so what this part here looks like when you got cos, cos, sine, sine. Remember, I'm not going to write too much over here, but when you have cos A plus B, so this is from your trig and your prelim work, you get cos A, cos B minus sine A, sine B. And that matches up with this pattern here. So what I can do is I can write this part here as the sum of two angles, so the cos of them. So we go cos theta 1 plus theta 2. And the same thing over in this part over here. So what we'll do is we'll notice we've got an I in both of them, so we can take that out as a common factor. And we've got sine of, let's call it A, cos B, plus, and this will be the sine of B cos A. So it's sine cos and a cos sine. You can rearrange these, which matches up with your double angle results, or your sums of sine A plus B. It's not an A, it's a theta 1 plus a theta 2. Now that there is your rule for multiplying complex numbers, and that's the reason it works. I'll let you have a look at the video, Okay, so what you can do is you can look on page 38 for the proof of the division, which is this one. It involves multiplying by conjugates on conjugates. It's quite easy to follow algebraically. What I want to do now is show you just how to do a very quick example, and then you can have a go at these yourself. So let's say we want to multiply 5 cis 150 degrees, so it's written in cis form, which is mod arg form, by 2 cis 70. So because it's in mod arg form, we can multiply the moduluses together. So this is 10, and because it's a product, we can add their two arguments, so we get sine of cis of 220. Now remember, 220, this argument has to be between 180 positive or around to negative 180. So I just need to change 220 into minus 140 degrees. So we write 10 cis minus 140 degrees. Then you've multiplied two complex numbers in mod arg form. Thank you.